Okay, so now we're going to look at the charge of a cation in an ionic compound or ionic compounds. You should have either printed off the worksheet or have a PDF of it ready to annotate on it. The worksheet looks like this. Notes charge of cations and practice 1. Worksheet looks something like that. Okay, so here's what you're going to do. First thing we're going to do is we're going to go through these steps. To find the charge of a cation that has multiple oxidation states, positive charges, follow the following steps. Split the compound after the cation. There is an exception to that, but we will not be using the exception. Look up the charge of the anion. Note the charge of the anion. Adjust the charge of the anion if needed, and adjust the charge of the cation if needed. Now, for the most part, the split the compound after the cation will be pretty simple. Every once in a while, and this is the exception that we won't use very often. I said never a moment ago. I really should have said won't use it very often. Every once in a while, the exception to this will be, hold on just a second. Apologize, trying to get my pen ready. Okay, so if it starts with NH4, right, and then has something with it, whatever this is, X, or if it starts with H3O with some other, you would split that compound then here, right after the NH4, after the H3O. Now that's typically not going to be something I would give you, but that is a possibility out there in our world. Okay. So here we have, and these are going to be in a kind of a weird number order. You're just going to have to follow along with me. I don't want to go back in and take the time to reset it. It'll take a lot of my time when I can just do this in this way. So here's what you're going to do. You're going to split the compound. Okay, you're going to split the compound right after the cation. That means the positive ion, or right before the anion. So if, for instance, I'm going to split this here. Okay, and then I'm going to look to see. Okay, so I said split the cation. We're going to look to see how many BRs we have. It's monatomic, so there's no subscript with it. So that means that I'm going to look up BR down here. I'm going to see BRs a -1. So 1 minus, and there is one of them because there's a 1 here even though I don't see it. So this side is -1. So this side must be +1 because there's also a 1 here. So then this would be Cu 1 plus and Br 1 minus. All right, for this example, we're going to split it right after the cation or before the anion. We're going to say I have one of these times its charge of a -2. So that's a -2. So this has to be a +2 because there's only 1 here. So we would take the number times the charge for the negative and get a total. And then we come over here and we say we have to have the same value of number. So 2 and 2. This side's positive. How many do we have? 1. So 1 times what gets me to +2? 2. So then I know that this has to be Fe2 plus and S2 minus. Okay, another example. I'm going to split this right after the cation. The next step will be to consider the charge of the anion. So this is a -3. There are 1 of them. Okay, so you can do the charge times the amount, or you can do the amount times the charge. So how did I know that this was -3? You got to look it up. I find it down here. Okay, so this is -3 times 1, so this is a total of a -3. That means this side has to be +3, otherwise they would have an overall charge, and they don't. It's a compound. So how many TCs do I have? 1, so that means this stays as a +3. So this is TC3 plus, and this is N3 minus. All right, you go pause the video and you go try 4, 5, and 6 on your paper. Okay, I'm assuming you paused it. Let me go through this with you. If you don't try these on your own first before writing it down, it's really not going to help you know if you understand it. So please be in a habit of pausing the video and then finishing examples. So I'm going to split this. I see that this is a -2. Why? Because oxygen is a -2 when it's with no other atoms. There's 1 oxygen because there's nothing here. So -2 times 1 is -2. So this side has to total a +2. It has to be positive than negatives. There's only 1, so then I know this is Re2 plus, or +2, I don't care which way you write it, and O2 minus. Okay, you should have tried 5 already. If you haven't, pause it and try it now. Split it. This is a negative 3 times 1, so this has to be a positive 3. There's only one of these, so this is Mn, 3 plus, and P, 3 minus. Try it for number 6. If you haven't paused and try it on your own, please. So you're going to split it. This is a minus 1 times 1. How do I know chlorine's a minus 1? Chlorine with no other atoms is a minus 1 charge. There's 1 because there's no number. Remember, when monos don't have a number with them, then there's just 1 to have, right? So this is mono and it has 1, so this side has to be a plus 1. And there's only 1 here, so this would be AU 1 plus, Cl 1 minus. Okay, moving on. So example 7, you're going to split it. You're going to check the negative. Br is a minus 1 and there's 8. How do I know that? Because Br is a minus 1. I have 8 of them, so negative 1 times 8, so this has to be a positive 8. I can bring this 8 up times a negative 1 because it's part of the mono. Okay, so this 8 doesn't normally go with bromine. That's how I know I can use it in my multiplication factor. That means there's 8 of these. There are only 1 OS's, so it's going to be OS 8 plus and Br 1 minus. Split the compound. I know that there are negative 2 because oxygen by itself is always negative 2. This is peroxide. I will never use this. Mrs. Peachy will never use this, not intentionally at least. So know if you have an O, it's oxide. So it's a minus 2, and I have 2 of them. So that side's a minus 4, so this has to be a plus 4. There's 1 of these, so therefore this has to be W4 plus, tungsten 4 plus, and oxygen 2 minus. That's how the ions are that make up that compound. Okay, I'm gonna do this one with you. Let me try that again, sorry. So we're gonna split this. We're gonna say phosphorus by itself is a 3 minus. So I'm gonna take 3 minus, there's 2 of them, so this is minus 6. So this side must be plus 6. There's only 1, so I know that it's a plus 6. So OS 6 plus and P 3 minus are the 2 ions that make up that compound. All right. You try 10, 11, and 12, please. Pause the video. I'll go over the answers with you in a moment. Okay, hopefully you did that and you're back. So now we're going to split this. We know oxygen's a minus 2. Oxygen with no other atoms is a minus 2. So minus 2, but there's 3 oxygen atoms. So 3 times negative 2 is a negative 6. There's only 1 chromium. So we know it has to be the whole charge. So that would be the 2 pieces that make up that. Hopefully you've already tried 11 and 12. We're going to split this. We're going to see that nitrogen's a minus 3. It's right here. There are 2 of them. So that's a negative 6. Making this has to be a 6 plus because there's only 1. So this is going to be Ru 6 plus and N 3 minus. Split the compound. Okay. We see that S by itself is a minus 2. When I say by itself, I mean not with any other atoms. Like this is S with oxygen. No, there's not oxygen here. So it's just S by itself. So it's going to be negative 2 times 2, which makes negative 4 on this side. So this side must be total of a plus 4. There's only 1. So it stays, it takes all of it. It's 4 plus and S2 minus. All right, looking at 15. Now this time we're going to split it, and we're going to split it still before, right after the cation. I'm going to split it here. It doesn't really matter where you split it. But let's think about the fact that this is a phosphorus. Phosphorus is a minus 3. So negative 3 times 1. This side's negative 3. This side has to be positive 3. But there's 1 of them, so now we got to divide so that we know IR has to be plus 1 because this had to be a total of a 3 plus on this side, but there was 3 of them, so I have to divide on that side to figure out the charge. All the other problems we've done so far, we were dividing by 1 because there was only 1 there. That's why it wasn't as complex as this. Okay, so we're going to split this. We're going to see that this is a minus 2 times 1. Sulfur is a minus 2 when it's by itself with no other atoms. So this side is minus 2. This side must be plus 2. We're going to divide these, right? And we're going to get Au to be a 1 plus and sulfur to be a 2 minus. Okay, you try 17 and 18. Sorry, pause the video and try 17 and 18 on your own, and then check back in after you pause. Welcome back. So I'm going to split this. I'm going to see that nitrogen is a -3 times 1, so this must be a +3, but there's 3, so I'm going to divide. So Cu is 1 plus in this case, and N is 3 minus. Split it. I see that I have oxygen is a -2 and there's 1, so this is a -2. This side must be +2 then. And I'm going to divide 2 by 2. So I get IR to be a 1 plus and O to be a 2 minus. As always, reach out if this is confusing for you. Okay, looking at this one. Now we have changed something. Now we have polyatomics. So what we're talking about here is that this is a unit, this is a unit, this is a unit, and this is a unit. I'm going to split it still after the cation. That's usually going to be a metal. So I'm going to split all of these like that. You'll be doing these on your own in a few minutes. So this time I'm going to say, okay, remember that I have, this is a unit. So I'm going to look up this unit, Cn. So I'm looking up Cn, and I'll need to go down some on my screen here. Cn is a -1 charge, so just like we did before, this overall has a 1 minus charge, and there's 1. How do I know there's 1? Because there's no parentheses around them, okay? Meaning that there is just 1 unit, okay? So this is a -1, so this has to be a +1, and there's 1. So this is Cu 1 plus and Cn 1 minus. Here, this is a unit. So I'm looking for the NO2 unit, and you're going to find it right here. And it's a -1, so -1 times 1. Now, we don't use this 2 to multiply through like we did on the monatomics because NO2 is the unit. NO2 is the full unit. Okay, so there's only one of this unit of NO2. So -1 times 1 is -1, so this must be a +1. So this is IR 1 plus, NO2 1 minus. Okay, we're going to split this compound here. Okay, here's my unit. Split this compound here. Here's my unit. Okay, so this is a unit, SiO3. I'm going to look for that unit. It is right here. So I know that I have a -2, and there's one of the unit because the whole unit is SiO3. So this side's -2. This side must be +2, and there's one of them. So it's Cu 2 plus, SiO3 2 minus. Okay, looking at this one, yes, there's more than 2 letters, but that is a unit. Remember, these are polyatomics. Remember, polyatomics. Okay, so then we're looking up a unit of C6H5O7. C6H5O7 is a -3 charge, so -3, but there's 1 unit because there's no parentheses around it. We're going to talk about parentheses a little more in detail in a moment, but it's just a unit by itself, so there's 1 because there's no number telling us we have more than one of this unit. So this is a -3. This must be a +3, and there's 1. So this would be MO3 plus and C6H5O7 3 minus. You try 23, 24, 25, and 26. Please pause and try those. Okay, welcome back. I'm assuming you've tried those. So I'm thinking about the fact that BrO3 is over here. It's bromate. So it's a -1. There's 1 unit of BrO3 because BrO3 is the polyatomic unit. So that's a -1. So this must be +1 total. But I only have 1. So then I know that it's Ru 1 plus and BrO3 1 minus. Here's a unit of C2O4. I'm looking for C2O4 and I see it down here. It's a -2 times 1. So this is -2. So this has to be a total of a positive on the positives, +2 on the positive side. There's 1 of them. Right, so 2 divided by 1 is 2. So this is going to be Ru 2 plus and C2O4 2 minus. Okay. And then I'd like you to try 25 and 26 if you haven't paused. Pause and do that. Welcome back. So we're going to split this. This is the unit. Split this. This is the unit. Remember, we're splitting it right after the cation. So I'm looking up a unit of O and H together. That is a polyatomic, even though it doesn't feel like it. It is this polyatomic right there. So this is a -1 and there's 1. Sorry, -1. Let me try that again. -1 and there's 1, right? Because there's only 1 unit, no parentheses, 1 polyatomic OH unit. So this is a -1, so this side has to be +1 and there's 1. So Au 1 plus, OH 1 minus. Okay. This is a unit of ASO3. I can see it here. and it's going to be a 3 minus, and there's 1. Okay, a 3 minus, and there's 1 unit. One of the ASO3 units, so that's negative 3. So make this plus 3. So we'd have it as RH 3 plus and ASO3 3 minus. You should be filling out your notes because you're going to get credit for doing the notes. Okay, so now we have some other examples here. We're going to split this right here, just like we've been doing, and just right here, and then we look at the unit and the unit. This is a polyatomic. It's right here. Let's see, where is it? There it is. Minus 2 times 1 of the unit. Why is there only 1? Because there's no parentheses. So this is a negative 2. This must be a plus 2, but there's 2 of them, so I got to divide. So that makes it go to 1, because 2 divided by 2 is 1. S2, O3, 1 minus. Here, this is a unit. I find it over here, right there. Negative 3 times 1 of the unit, because there's no parentheses. So this side totals to negative 3. This must be a positive 3 in total, but there's 3 of them, so I divide. So that 3 divided by 3 is 1, so it's IR 3 plus, PO3 3 minus. You try 29 and 30. Pause the video and try them on your worksheet. Check back in a moment. Welcome back. So I'm going to split that there. Look up this unit. C4H4O5. C4H5 is a minus 2, and there's 1 of that unit, right? C4H5, I can see the unit, what it looks like down here as a unit. So then this is a negative 2. This side must be positive 2. Divided by 2 that are present. Normally there's just 1 there. This time there's a number. So AU 1 plus and C4H4O5 2 minus. I realized a moment ago I made a mistake here. I should have said 3 divided by 3. This should have been a 1 plus. This should have been a 1 plus. Because 3 divided by this 3 gives us a 1. Go back and fix that, please. Sorry about that. So split this compound and go here. So I'm looking at the unit of ASO4. I see it here. It's a negative 3. There's 1 of that unit. So there has to be a positive 3 on this side because this equals negative 3. So I divide it by 3. So it's going to be CU 1 plus and ASO4 3 minus. I also realized that I made a mistake up here. So let me go through these again. Go back and fix these. So you should have seen that this was a minus 2 times a 1, which is minus 2, which means we have to have a plus 2 divided by 2. That's how I got the 1, but I made a mistake here. This should have been minus 2. Hopefully you caught that before I fixed this. Sorry about that. I was in too much of a hurry. Apologize. Here we said PO3 is a minus 3, and there's 1 of them. So that's negative 3. This side must be a plus 3, and I had 3 to divide, so that's why that should have been a plus 1. Okay, now we have parentheses. That just tells us that when I split it, I have 2 of the unit inside the parentheses. When I split this, I have 3 of this unit. Okay, so here's how this works. Same as before. I'm going to look up the unit, CR207. I see it right here. There are 2 of them, or negative 2 of their charge is negative 2 times 2, which gives me a negative 4. This side must be plus 4. But there's 1 of them, so it's going to stay plus 4. So V4 plus and CR207 2 minus, because the charge was a 2 minus. Okay. All right, here we split it. We look up the unit. WO4 is a minus 2. So minus 2 times 3 of them. This 3 outside the parentheses says I have 3 of what's inside the parentheses. So that's a minus 6. So this must be 6 plus 6, or 6 plus, and there's 1 of them, so it stays as 6, so it's RU 6 plus and WO4 3 minus. Okay, split it after the cation. Look up this unit. Parentheses tell me I have 2 of the unit inside the parentheses. I find it to be a minus 2, a minus 3. So I'm going to take minus 3 times 2, which is negative 6. This is a 6 plus or plus 6. I don't care which way you write it. There's 1 of them, though. So this is RE 6 plus and ASO4 3 minus. Split this compound here. Look up this unit. You see that PO3 down here in the very bottom. And remember that this is on the back side of your periodic table. So PO3 is a negative 3. But I have 2 of the unit from this. Tells me I have 2 of what's inside the parentheses, so I have a negative 6. This is a positive 6 then. I have 1 of them though, so 6 divided by 1 is still 6. So CR 6 plus and PO3 3 minus. Please do 35, 36, 37, and 38. Pause the video, do it on your worksheet, check yourself. Welcome back. So we're going to split this compound here. We're going to look up this unit. We're going to see ASO4 is a minus 3. So minus 3 times 2 is negative 6. This is a plus 6, but there's 1 of them. So it stays a 6. So TC 6 plus and ASO4 3 minus. Look up this unit, split it. Look up this unit. C6H5O7. C6H5O7 is a minus 3. So negative 3 times 2 is negative 6. This is a 6 plus, there's only 1, so it stays as OS 6 plus, and C6H5O7 3 minus. 37 and 38, you should have tried on your own. If you haven't, pause and try them and then check in with me on the answers. Split it, looking up C2O4. C2O4 is right there. It's a minus 2, and there's 3 of them because of the parentheses, so negative 6. This makes this a plus 6, and there's 1, so it stays 6, nothing to divide by except a 1. That would be the plus and minus for that. Split it. Look up this unit. This is a minus 2 right here, times 2, which is a negative 4. This must be a positive 4. There's 1, so we've got TC4 plus and C4H4 O6 2 minus. All right, last 4 examples. So split it like we've done. We have a unit. We're going to look up the PO4 unit. We see it over here. It's a minus 3 times 7 is a minus 21. So something is wrong with this one. Hang on, let me see. Okay, there should have been a 3 here. Your worksheet should be completed by the time you watch this video, but I did need to fix it on my screen. So this should be a 3, so fix that. So then I'm going to take, I need to get positive 21. Gotta get my pen working again. Hold on just a moment, please. Okay, so this should be a positive 21. Divide by 3. Making this TC 7 plus and PO4 3 minus. I'm going to do 41 and have you do 40 and 42. So I'm going to split this one. We're doing 41 together. You're going to do 40 and 42 on your own. I'm going to look up this unit. I'm going to see that it's a minus, where is it? Minus 2. So negative 2 times 3 makes this a negative 6. This must be a plus 6, but there's 2 of them. So that makes this actually be RH3 plus going with S2O3 2 minus. And you pause the video and try 40 and 42 on your worksheet and then come back and see how you did. So we're splitting this. We're looking this up and we're seeing that it's a negative 2 times 5 is negative 10. This has to be a plus 10. Let me try that again. Apologize for that. This is a negative 3. I looked at this too quickly. This is a negative 3 times 5, which is negative 15. So this has to be a positive 15. Positive 15. And there's 3 of them, making this W5 plus and C6H5O7 3 minus. Split this. Look up this and see that it's a negative 2 times 3, which is negative 6. So we need a 6 plus here. 6 divided by 2 is 3. So MO3 plus, and then S2O3 2 minus. All right, so you are now going to get into Schoology, most likely, and complete a practice assessment, practice quiz. Look for instructions on that in your Schoology folder.